Hello viewers, welcome once again back to my channel Math Made Easy with PDY. As usual, if you want to get in touch with me, you can reach me on the following numbers down here. Thanks so much for subscribing to my channel both on YouTube and then Facebook, and also to my Telegram channel. It's a great privilege coming your way with another lesson. Now, in today's lesson, we are actually going to look at what we call the quadratic formula. Sometimes we always say the almighty formula. We'll be looking also at how the almighty formula or the quadratic formula can be used to determine the nature of roots of a particular quadratic equation. Without wasting my time, let's get going. Have you ever wondered, you being given a question, find the solution set of 9t squared plus 12t plus 4 equal to 0 in section A, for which there are so many ways by which you can come up with the answer. If you want to know how to go about it using the calculator, I've shown that in some of my previous videos, so you can actually click the link above to get to the video of this lesson using the calculator to solve quadratic equations. And also coming along with solve 2x squared plus 6x minus 3 equal to 0. How do you solve this? So you can use so many ways of getting it done, but one particular way you can solve it is to use the expression for this question. Then we can say it is t is equal to minus 12 plus or minus square root of 12 all squared minus 4 times 9 times 4, all divided by 2 times 9. So you can use a calculator to simplify some of them. So t will be equal to minus 12 plus or minus 12 squared is actually going to give us an answer of 144 minus 4 times 9 times 4, that is going to be 36 times 9. Sorry, that is 36 times 4. 36 times 4, giving you an answer of 144 as well. So in this case, what it means is that all this must be divided by 18. And therefore, our t value will be equal to minus 12 plus or minus square root of 0, all divided by 18. From here, you realize that you are having t equal to minus 12 on 18. Minus 12 on 18. And when you simplify minus 12 on 18, you are going to get an answer of t equal to minus 2 on 3. But remember, we had plus or minus 0. So it's either minus 2 on 3 plus 0 or minus 2 on 3 minus 0. And it's going to give you two answers, which is t equal to minus 2 on 3. So this is a repeated solution, minus 2 on 3. So the possible answer is D. The possible answer is D. Now, with the same idea, we can use it to solve this question. This time around, the variable is x. So it's going to be x is equal to minus 6 plus or minus square root of 6 all squared minus 4 times 2 times negative 3. And in this case, all this must be divided by 2 times 2. Simplifying, we will have it as x equal to minus 6 plus or minus square root of 6 squared is actually 36 minus 8 times 3. The negative will make it plus, so we are going to have it as 24. 8 times 3, 24, all divided by 4. Going further, x will be equal to minus 6 plus or minus, simplifying 36 plus 24, that will give us an answer of 60. An answer of 60. So we have square root of 60, all divided by 4. Now you realize that square root of 60 can be simplified. Square root of 60 can be simplified. So square root of 60 gives us an answer of 2 root of 15. 2 root of 15. So if we have 2 root of 15, then our x value is either going to be x is equal to minus 6 plus or minus square root of 2 root of 15, all divided by 4. Now let me just create a space here to simplify it further. So 2 root of 15 plus or minus of negative 6, we are going to have two answers to this. So we have x equal to minus 6 plus 2 root of 15, all divided by 4, for which we are going to factorize out 2. So you have x equal to 2 out, negative 3 plus root of 15, all divided by 4, for which the 2 can do away with 2 at the 4, so it will be level 2. So x is either negative 3 plus root of 15 on 2. So this is one solution, and the other solution is going to follow the same procedure, but there's going to be a subtraction sign between the negative 6 and then the 2 root of 15, whereby when you simplify it as well, it's going to be, so we have x1 as this, and then x2 will be equal to negative 3 minus root of 15, all divided by 2. So it's either negative 3 plus root of 15 on 2 or negative 3 minus root of 15 on 2. Therefore, the possible answer to this question is supposed to be possible answer C. Possible answer C. So someone may ask, how was I able to come up with this expression t equal to that, x is equal to that, to get the solution done faster? It's actually a formula or a rule which is used to solve the quadratic equation. It's a formula or a rule, and if you know how to apply it, you can just quote directly and use it without quoting the formula. So someone may ask, what then is the rule? What then is the rule? So from the expression, quadratic equations are given in the form ax squared plus bx plus c equal to 0. Now a rule was deduced which helps you to solve the quadratic equation, and that rule is x is equal to minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So someone may ask, how was this rule deduced? How was this rule deduced? And that is what I'm going to show you right now, so that we also know how to apply it and when to apply them as well. So then again, I said from this quadratic formula or quadratic equation, from a quadratic equation given as that this formula was deduced. The formula was deduced, which is, we say, the almighty formula. It was deduced out of that. So without wasting my time, let us go through how this formula was deduced. So if we have ax squared plus bx plus c equal to 0, using the idea of completing of squares, we are going to make x the subject. But how do we make x the subject from here? We first need to see to it that the coefficient of x squared is 1. So we are going to divide through by a, the whole expression by a. So the left hand side divided by a, the right hand side divided by a. And that will be giving us as squared divided by a, which will be left with s squared. Then we have b on ax plus c on a equal to 0. Then we group, because we want to make s a subject, we are just going to transpose the c on a to the right hand side. So we'll be left with s squared plus b on a x equal to negative c on a. At this point, making x the subject, we are going to make the left hand side a perfect square so that we can write the expression here in a factor form, which will be in terms of x and only b on a. And whatever operation we work on the left hand side, the same operation must be done on the right hand side of the equation. So we are going to select the coefficient of x, half it, square it, and then we add it to both sides of the equation. It's a 3-in-1 operation. Again, select the coefficient of x, half it, square the solution, and then add it to both sides of the equation. So when you select b on a, when you half it, you are going to obtain b on 2a. Then you square the operation or the solution. Then you add it to the left hand side, and the same answer must be added to the right hand side. So plus b on 2a all squared. At this point, the operation on the expression on the left hand side has become a perfect square. So you can write a factor for that perfect square, and that will be giving us x plus b on 2a all squared. Now, what it means is that since this is a perfect square, when you expand the expression x plus b on 2a all squared, you are going to get that answer. And hence, this must be equal to, the right hand side is still going to be negative c on a, plus we can simplify this to obtain b squared on 4a squared. B squared on 4a squared. At this point, we can merge it, and in doing so, on the right hand side, the LCM is going to be 4a squared. A will go into 4a squared, 4a times, multiplying negative c, we have minus 4ac. Then plus 4a squared goes into itself once, multiplies b, we have b squared. Then we have the left hand side still being x plus b on 2a all squared. Since we want to make x a subject, then it means with the idea of change of subject, we have to do away with the square and do away with the b on 2a so that x can stand on its own. And in doing so, we have to find the square root on the right hand side of the equation. So this is going to lead us to x plus b on 2a, and this will be equal to square root of, let me just regroup this as b squared minus 4ac all on 4a squared. Now, you bear with me that this solution that we are expecting to obtain is supposed to be 2. So since it's supposed to be 2, then it means when the square root is introduced, we have to add the plus or minus, because the S value is expected to be two solutions. So whenever you are finding the square root on the right hand side, you introduce plus or minus. The reason for that is, if I have a perfect square and that perfect square is 4, now 4 being a perfect square, two factors that gives you the same number 4 is -2 or +2. So when you square -2, you are getting 4. When you square +2, you are also getting 4 as well. That is why when you find square root of a perfect square, there is a need for you to always introduce a plus or minus to that square root sign. Good. So if that is understood, let's continue. So let me clean this so that we continue with our X being the subject. Now, then we can now transpose the plus b over 2a to the right hand side. So we are going to obtain X is equal to b on 2a negative, plus or minus. When we simplify this expression, when you have square roots affecting a fraction, the square roots affect both the numerator separately and the denominator separately. So we are going to have square root of b squared minus 4ac all on square root of 4a squared will give us square root of 4 is 2 and square root of a squared is a. So we are left with that. So at the end of the day, X is going to be minus b on 2a plus or minus square root of b squared minus 4ac all over 2a. But we can merge these two fractions because they are having the same denominator, and therefore merging it, X will finally be common LCM, which is 2a, and we have minus b plus or minus square root of b squared minus 4ac. So my dear students, this is what we call the almighty formula, which is used to solve quadratic equations. This formula over here has a very great impact on quadratic equations, and it tells us so much about the type of solution you should be expecting whenever you are solving a quadratic equation. It tells us so much what you need to expect whenever you are solving a quadratic equation. And in this case, going further, X equal to minus b squared, minus b plus or minus square root of b squared minus 4ac all on 2a. The expression b squared minus 4ac is known as the discriminant. This is known as the discriminant of the expression or the equation. What does it do? It actually determines, the discriminant determines the type of solution to obtain from the quadratic equation. So the discriminant determines the type of solution set to obtain from the quadratic equation. What do we mean by it determines the solution set? Now, if it should happen that the discriminant, which is b squared minus 4ac, is a number which is greater than 0, then it means you are going to obtain what we call two real solutions. Now, the word solution can also refer to roots. It means whenever you solve the quadratic equation, you are going to get two real numbers. It can be two positive numbers which are different, or it can be two positive negative real numbers which are also different. So that is what we mean by two real solutions. Now you can also add the word distinct. Distinct meaning they are different. They are not going to be the same number. It's going to be two different solutions. For example, remember we had a question over here, and the solution that we had over here, we had the first answer as x1 being -3 plus root of 15 on 2, and the second is -3 minus root of 15 on 2. So this is a perfect example of obtaining a solution which is two real distinct values. Two real distinct values. We'll be taking some examples so you understand it further as we go on. Then again, the discriminant as we have here can also be a value. B squared minus 4ac can be a value which is exactly equal to 0. So when the discriminant is equal to 0, then we say that you are going to obtain two real same solution. Two real same solution or roots. Yes, meaning you are going to obtain the same answer. If they are negative numbers, they are going to be the same negative numbers. If they are positive numbers, they are going to be the same positive numbers. And a perfect example is the one we had here. So find the solution set of 9t squared plus 12t plus 4. Now when we worked it out, we had the answer as t being -2 on 3, which is repeating itself. So in other words, this is a perfect example whereby we could have used the discriminant to determine the type of solution we are going to obtain. So that is a perfect example to that effect. Now, so either it is two real same solution, or you can say that it's going to have what we call a repeated root. A repeated root, or a repeated solution. A repeated root or a repeated solution. Then the last but not least, for which the discriminant does, is we may have b squared minus 4ac going to be a number which is less than 0. So when it's a number less than 0, then it is going to tell you that you are going to have two imaginary roots or solution. So two imaginary roots or solution. In other words, we can also say that it has no solution. When we say imaginary, then it means that it exists in an imaginary world. It doesn't have an actual value in the real world. So on your calculator, it displays some symbols like I. It displays some symbols like I. So either two imaginary solution, or you can also say that it will have no solution. No solution when it comes to the real world. So my dear students, this is the main focus of the quadratic formula, not only being used to solve quadratic equation, but you can also use it to determine the type of solution that you are going to obtain. The type of solution you are going to obtain. I have some set of questions here I would like us to go through with respect to the use of the quadratic formula. The use of the quadratic formula. So let's go through fast and see how best we can use the quadratic formula. Now I have first two examples here which says find the values of m for which the equation x squared minus mx plus 4 equal to 0 has equal roots. So remember, the word is equal roots. Therefore, in order to go ahead solving this question, you should know that the discriminant will help us a lot in getting the answer to this question. Remember, when the quadratic equation has equal roots, then we learned that the discriminant is supposed to be equal to 0. So from whatever we learned early on, we learned that the discriminant b squared minus 4ac, when it's equal to 0, then it means the quadratic equation has equal roots. Therefore, from our quadratic equation, which has a missing coefficient for the x term, considering s squared minus mx plus 4 equal to 0, let's generate our a, b, and c from it. Remember, our a is the coefficient of s squared, so a is equal to 1. Our b, the coefficient of x, which is minus m. Then our c is equal to 4, which is a true constant. So let's substitute this into our discriminant. So we have it as minus of m all squared minus 4 times 1, then times c value, which is also 4, and this must be equal to 0. Therefore, we are going to have m squared here, then we have minus 16 equal to 0. M squared will be equal to positive 16. Therefore, m will be equal to plus or minus square root of 16, and m will be equal to plus or minus 4. Therefore, it tells us that the m value must be either positive 4 or negative 4 in order to make our quadratic equation here become a perfect square or have equal roots as its solution, which is the possible answer C. Going to the next example, what value of m makes the expression a perfect square? So then again, you should understand what a perfect square is, and what it means is that you have a number which is repeating itself, So that's what it means, and that makes it a perfect square. So some perfect square that we have in our real number system include 0, 1, 4, 9, and goes on. 0 times 0 gives you 0. 1 times 1 gives you 1. 4, you have 2 times 2. So it's a repeated number multiplying itself to give you that perfect square. So in order to determine the value of m, then again we can still use the discriminant to get the answer to the question. So we can say that if we have s squared minus 6x plus 36m, generating this is a quadratic function, generating our ABC, we have a equal to 1, b equal to negative 6, and then c equal to 36m. And from here, with our discriminant being known as b squared minus 4ac equal to 0, because it's supposed to be a perfect square, substituting our a, b, and c, we are going to have it as minus 6 all squared, then minus 4 times a value 1 times c value, which is 36m, and this must be equal to 0. So we have 36, then 4 times 36 from the calculator, we have an answer of 144. So we have negative 144m equal to 0. Now, grouping terms to solve m, we have negative 144m equal to negative 36. Divide both sides by negative 144. Then m value will be equal to what? So 36, 144, you have an answer of positive 1 on 4. Positive 1 on 4, which is possible answer B. So, my dear student, I believe you are following this carefully. If you don't understand anything, you can pause the video and go back and review it. Now, going further, we have other examples as this. Find the values of k for which the equation x squared minus kx plus 4 has equal roots. It has equal roots. I believe from the two examples that I've done early on, you can get it done. So try your hand on it and give me the feedback at the comment section. Get me the feedback on at the comment section. Now, let me try the question number 36 here with you. Let me try the question number 36 here with you. So have equal roots. So you can see for equal roots, what do you expect the discriminant to be? The discriminant should be equal to 0. But this time around, you realize that you don't have only the missing value being 1. It's just cutting across. So someone may say this question might be a bit difficult. No, it's the same idea. Just know how to select your coefficients for the discriminant and then use it perfectly. So let us solve the question number 36. And having our expression given, b squared minus 4ac should be equal to 0. Our a value is equal to k from the question. Our b value is equal to k plus 2, which is the coefficient of x. And then our c value is also k. Then let's substitute it. So we have k plus 2 all squared minus 4 times k and also times another k. And this must be equal to 0. So when we expand this, we have k squared plus 4k plus 4 minus 4k squared. Minus 4k squared. And this must be equal to 0. Now you realize that we are having a quadratic equation again then to solve. But k squared has a like term of negative k squared here. So we are going to have it as minus 3k squared. Minus 3k squared. Plus 4k, then plus 4. And this must be equal to 0. So being able to come up with this quadratic equation for which we need to solve, then you can go for the quadratic formula. The quadratic formula, which is the almighty formula to make the work faster. Or if you know how to use your calculator, you can use the calculator to get it done. By using the quadratic formula, so k must be equal to minus of b, which is 4, plus or minus square root of b squared, which is 4 all squared, minus 4ac, which is 4 times negative 3 times 4, all divided by 2a. So 2 times negative 3. Now simplifying, we can say we have k equal to minus 4 plus or minus, when you simplify the square root, we have 16 plus 16 times 3. 16 times 3, you have it as 48. All divided by 2 times negative 3, which is negative 6. Let me just write negative 6. So k will be equal to minus 4 plus or minus 16 plus 48. You have an answer of 64. Square root of that, all divided by negative 6. Now, square root of 64 is 8. So we have k as negative 4 plus 8 divided by negative 6, or k is equal to negative 4 minus 8 divided by -6. And simplifying, k will be equal to 8 minus 4 is actually 4. So 4 on -6. And then -4 minus 8 will give us -12. So we have k equal to -12 on -6. Final answer, k then becomes either -2 on 3, or k will be equal to positive 2. Positive 2. So when we go through the possible answers, you realize that we have +2 and -2 on 3, which is as possible answer A. Possible answer A. So my dear student, please do your possible best to know how to use the quadratic formula to determine the quadratic equation solution, or to use it to determine some missing coefficients in given quadratic expressions. So we have another one here. And that's my last example. I want us to give it a try. It says that if 4x squared plus 5kx plus 10 is a perfect square, find the value of k. So still, you need to use the discriminant to determine the value of k. Therefore, our discriminant is b squared minus 4ac. But because it's a perfect square, for the value of k to be obtained, then we have our discriminant to be equal to 0. Let's select our coefficients. Our a is going to be 4, our b is equal to 5k, and then our c is going to be 10. Substitute it in there. You have it as 5k all squared minus 4 times 4, then times 10, equal to 0. So we have 25k squared minus 16 times 10 is 160, equal to 0. So solving for k, we have 25k squared should be equal to 160. Divide both sides by 25, and what are we going to obtain? 160 divided by 25, you have 32 on 5. So we are having k squared is equal to 32 on 5. Finding the value of k then will be equal to plus or minus square root of 32 on 5. And remember, in getting this, you have to simplify. So square root of 32 on 5, k will be equal to plus or minus have it as 4 root of 10 all over 5. 4 root of 10 all over 5. So either k value is positive 4 root of 10 on 5 or negative 4 root of 10 on 5. And that will make the expression here a perfect square. So going through the possible answers, then we have a positive 4 root of 5, 4 root of 10 on 5 over here. And that's possible answer A. Thanks so much for joining the call. I'm privileged to come your way with this video. I believe you've learned something. I want you to support my channel by subscribing and then sharing the link of this video to your friends, so that together we can make math lessons easy to understand. Thank you, and God richly bless you. Have a nice day. Bye-bye.